is just some kinetic molecular theory. So kinetic molecular theory was conceived to try and explain like why states of matter behave the way they do. So not just saying, hey, we know that liquids take the shape of their container, but kinetic molecular theory actually tries to say like why does it behave that way. So there's a couple assumptions that they have about kinetic molecular theory and a couple things that just are background knowledge. So that's what we're going to go over, and then what we're going to do is go through each state of matter as a formal thing. So what we have here is that the first thing is that kinetic molecular theory is that when you have matter, that particles have to be in motion, and they're in constant motion, and that's just a general thing that all matter does. Another thing is that there is kinetic molecular theory deals with kinetic energy, and if you remember, kinetic energy is the energy of motion, and there is a connection between that and temperature. So there is a formula here for kinetic energy, and that is that it's 1/2 the mass in kilograms right here times your velocity squared, and the velocity has to be in meters per second. So again, everything has kinetic energy, and everything has mass. So if everything has kinetic energy, everything has mass. Everything has to have some velocity. It has to have some movement to have kinetic energy, and everything does. So that's the major thing of it. So when you have a sample, you actually have some particles moving really fast, and you have some particles that aren't moving as fast. And what we talk about is average kinetic energy. So here's just a nice diagram of it. The blue line is obviously our colder sample, the red line is our warmer sample, and what you can see here is that in the colder sample, we still have some molecules moving really, really fast, and they have a lot of energy. But what you can see is if you're looking at it overall, there's more molecules down here with less energy, and that's what gives it the lower average kinetic energy, and then also that's related to the temperature. So this is a lower temperature, means lower energy. The warmer sample here, you can see that it's a little more spread out, it's a nicer curve, and you can see that there's a higher proportion of molecules or atoms that have a higher energy, and that's what we're talking about with kinetic molecular theory. All right, so just two quick questions here. Which point on each curve represents the average kinetic energy? So you probably want to stop it, try and stop the video, try and figure it out, and hopefully you got it. But you can see here that the top point on both of these should be your average kinetic energy. So this right here, you're showing the most molecules have that, and if you average everything out, it should be right around that top point. Second question is, what would happen to the shape of the curve if the water temperature were even higher? And what we would see is that this red line, it would kind of smear out even further. So the red line would get even lower, and the curve would actually spread out further, and the average would move up farther on the energy graph. So we would get kind of like a different thing here. And if we were lower, if we had lower temperature, it would be an even sharper curve than this blue one. So it would get higher and tighter over to this left side, and the average point would be over further. And then just remember that, I don't know if I have it on here. Oh yeah, here we go. That the average kinetic energy is connected to temperature. Like, you definitely want to know that there is a relationship there.